Hey there, everybody. Okay, so the Gearbox project we've been working on in the CAD class is a pretty big project, especially for people that are new to Inventor. I think it's important because it represents, a pretty big achievement in terms of following an actual real-world design project through start to finish. So I want to make sure you guys can finish it and get that done and get that under your belts before we move on in the class. So I figured because it's taking too long to actually finish in the class, I'd record the process of modeling the gearbox and kind of explain some of the design choices along the way. And then you guys can follow along. So this is going to be fairly long. I estimate this is probably going to take an hour or two. Because of the lack of a time constraint for the videos, I'm probably going to model this in more detail than I would in the class. In other words, I'm going to add the fasteners and stuff here, and I'll show you guys how I do that because that's a pretty important thing to learn. I'm going to probably break this into a few different parts just to not have to handle a huge video file on my computer. So I've already got my project file set up. I have not downloaded any of the files. I'll show you guys where to download those from and kind of how to handle the files. This is assuming that you have your settings set up and your project file selected like we've been doing at the beginning of each class. I don't remember off the top of my head. This is just my personal computer, so I may have some settings that are a little different than we were using in the class. All right, so we're going to start with the layout sketch. For those of you who are in the class, we've already done this once, but I'm going to walk you back through it. And I'm actually going to do the layout sketch slightly differently than I did it with you guys. I did a kind of a more abbreviated version. But I'm going to do this the way that I would do it if I was designing the gearbox. And I'll explain exactly what that looks like. So, I've got the gears just kind of memorized in my head. So the first gear that we're concerned with is it's a 12-tooth 32 DP gear that's on the shaft of the motor. So what we're going to do is we're going to draw all the gears as construction circles. So I'm turning on construction geometry, picking the circle tool. Okay, then if you guys were in the class, well, what we're going to be drawing here as circles is the pitch diameter of the gears. Okay, and what this sketch is going to do is it's going to help us locate the centers of the holes that we're going to use for placing the bearings in the gearbox. So what we're going to be doing here is we're going to be modeling circles, and those circles are going to represent the pitch diameter of the gear. So this is a 12-tooth gear, and it has a 32 DP diametral pitch. So what we're going to do is we're going to type in an equation. We're going to do 12, which is the number of teeth, divided by the diametral pitch, which I just said is 32. Okay, that's a little equation. That results in 0.375 inches in diameter. This is the pitch diameter of a 12-tooth 32 DP gear. So now the circle tool is still active. Construction geometry is still on. So I'm going to come down here and I'm going to draw another circle. Now, the gear that this 12-tooth gear is meshed to is a 60-tooth. And once again, we're going to divide that by the DP, which is 32. Okay, now this gives us the pitch diameter of the gear that's meshed to this. Now, when two gears are meshed, their pitch diameters, their pitch circles, I should say, are tangent. So what we're going to do is we're going to get out of the circle tool. We're going to pick the tangent tool right here. To pick that, we're going to click one pitch circle, then we're going to click the other pitch circle. That makes them tangent. Now, in our gear, the different stages will be lined up vertically. So what we're going to do is we're going to pick the vertical constraint. We're going to click the center of one circle, then we're going to click the center of the other circle. I need to click this one first. There we go. Okay. So I think I misclicked something there. But anyways, I'm just gonna undo that. I'm gonna do it again. So vertical constraint, click. I should be able to click that one first, then click this one. Yeah, that works. I clicked something wrong. So, okay. So that's the first set of gears. Now we have another gear. So we're gonna go back to the circle tool. Our construction geometry button is still pressed down. That's still there from before. We're gonna create a circle on the center point. Okay. So this is gonna be a 16-tooth gear divided by the diametral pitch, which is 20. Now, we're going to do something a little bit different here. It's pretty common practice in FRC for the 20 GP gears that are sold by VEX to add a little bit of distance between the two gears to kind of mesh them farther apart than you normally would, and that just cuts down on wear, kind of makes the gearboxes run a little smoother and reduce wear on the gears. So what we're going to do here is we're going to add something to the equation. We're going to do plus 0.003. That's 0.003 of an inch, and that works out to 1.5 thousandths of an inch in the radius, right? And then there's on the gear that meshes to this, we're going to add another 1.5 thousandths, so it'll be 3 thousandths of an inch additional spacing between the gears. So press the Enter key. Then we're going to come down here and draw our final gear. So this will be 60 teeth divided by a DP of 20. Then once again plus 3 thousandths of an inch. Okay. Then we're going to do what we did before. We're going to exit out of the circle tool using the Escape key. Then we're going to pick the tangent constraint tool. We're going to pick this circle. We're going to pick this circle here. We're going to tangent those two. Then I'm getting out of the tangent tool with the Escape key again. Then I'm going to pick the vertical constraint tool. I'm going to click the center of these pitch circles and then click this pitch circle center here. And then that's all of our pitch circles in their correct locations. So I'm going to get out of the vertical constraint tool by pressing the Escape key, and we're going to move on. So next, we need to know the motor is going to be up here, and we need to know where it's going to be so that we can make sure the aluminum plate that makes up the major structural component of the gearbox, we need to make sure that that plate is big enough that the motor can bolt to it. So what we're going to do is we're going to draw another construction circle right here on this top circle, and we're going to make this the outside diameter of the motor, which is 1.756 inches. This is a 775 Pro motor. And I'm going to press the Enter key. Okay, so this circle does not represent a pitch diameter or a pitch circle. This circle represents the actual outside diameter of the gear. Okay, so next what we're going to do is we're going to create a rectangle around this whole thing. So what I'm going to do is I'm going to turn off construction geometry, and I'm going to pick the rectangle tool. Make sure this 2-point rectangle, you can see the icon with the 2 red dots at the corners. Make sure this 2-point rectangle is the one that's selected, and just kind of box around the whole thing. Now I'm clicking, just to reiterate, I'm clicking and clicking again. I'm going to undo that. I don't want that rectangle. I'm not clicking and dragging is my point. Okay, so we want this box around this gearbox, we want it to be centered left to right. So what we're going to do is we're going to use a vertical constraint to line up the center point. You can see it highlighted by this little green dot. When I get close to it, it snaps to it, highlights it with a little green dot. So if I click this and I click any of these 3 points, it's going to line up those 2 points vertically. It'll line them up vertically. So we're going to, that point selected, we're going to click this point second, and it lines up this gearbox. So now if I get out of the, I got out of the tool by pressing the Escape key. Now if I click and drag on this, you'll notice the other side moves an equal amount. So it's kind of symmetrical, which is what we want. Okay, so next, we're going to, we want So if this is the edge of our motor, right, we want the plate to end right at the edge of the motor. We could add a little bit extra, and maybe on a real robot I would, but for this particular motor, there's no reason to do that. So what we're going to do is we're going to make this line positioned right about here. It's going to make it tangent to this circle. So we're going to do that with the tangent tool. So we pick the tangent tool, we click the line, then we click the circle, okay, and you'll notice this line turns blue, which means it's fully constrained, which means it's positioned where we want. Okay, so now we need to know, so these gears are pretty small. I'm not worried about these gears. This gear here is pretty big, and we want to make sure that the gearbox covers the whole gear, even the gear teeth. Now, the way we do that, well, to back up, remember this is the pitch circle. So this here is not the outside diameter of the gear, right? This is roughly somewhere in the middle of the teeth of the gear. So the teeth of the gear are going to stick out on the outside of the pitch circle. So what we're going to do is we're going to draw a circle that represents the outside of the teeth of the gear. So we're going to pick construction geometry again. We're going to pick a circle. We're going to start it on the center point of this bottom circle here. We're going to click. We're going to move it out. Okay. Now the outside diameter of a gear is the same as the pitch diameter of a gear with 2 more teeth. Okay, so just to see how that applies in our situation, this is a 60 tooth gear and it's 20 dp. So the outside diameter of that gear is this pitch diameter of a 62 tooth gear. So we're going to put in the equation for that. It's 62 teeth divided by 20. Okay. Now we're not going to do the plus 3,000ths because we don't need it in this case. Then we're going to press the Enter key. So you'll notice it's just slightly larger than the pitch diameter, which is exactly right. Okay, so now this represents the outside of the teeth. There's nothing sticking out outside of this, so we can be pretty confident that this is out of the way, so to speak. Okay, so what I'm going to do now is we're going to just dimension this outer rectangle to size and eyeball a size that looks good to us and use nice fractional dimensions. So I'm going to pick the dimension tool. I'm going to click, actually I'm going to start at the top. I'm going to click the top line, and then I got to place the dimension somewhere that's readable. I'm going to place it down there by clicking. Now I see if 3.25 is good enough. Click the green check mark. So basically we just want a little bit of space on the outside of the gear, and we wanted a nice even number. You know, this is 3 1/4, which is a pretty manageable number. And then we're going to do the side. So we're going to do the same thing. Click on the line with the dimension tool active. Then we're going to place the dimension down somewhere readable. We're going to go, I think, 5.5. Yeah. Okay, so once again, we just want a little space. And basically, depending on what you're doing on the robot, you might not need the gear to be completely contained inside the plate. Like you could cut down the plate to save weight, but you got to make sure that stuff can't get caught in the gears, and you want to have a little bit of containment for grease and such. So typically it's common practice to kind of cover the profile of the gear with a plate, but you end up putting lightning holes in it typically. So that's really just up to the designer in this case. To make it simple, we're going to make this plate this size. So, okay, so we could extrude this rectangle now if we wanted to, but we need to have some holes here. So we're going to do something that's a little different than I did it in the class in person. So we're going to go ahead and add in the holes. So we need the motor has a little boss on it, and we need a hole for the motor shaft and that boss to fit through. Then obviously we need a bearing hole for each of these 2 sets of gears. So I'm going to turn off construction geometry. I'm going to pick the circle tool. So I'm going to do the hole for the motor first. Now I know that the boss is 17.8 millimeters in diameter. Now we don't want that to be a really tight fit, so we're going to make it 2 2/10 of a millimeter larger and just round it up to 18 millimeters. Now you can type this when I'm creating the circle here. You can type in dimensions in millimeters and just follow them by mm, like I've done here, and then press enter. So it'll automatically convert it to inches, and so if you're working with metric dimensions in a sketch or in anything in Inventor, you can just type in metric dimensions and it'll do the conversions automatically, which saves a lot of time. Okay, so now these two shafts here need a hole as well, which we're going to do with a non-construction circle once again. So we're going to place a circle here. This is going to be 1.125 inches. No, this is not millimeters, this is in inches. So we just type it in, no unit, and press enter. It makes a circle. And then we're going to do the same for this one. It's the same size, so it's going to be 1.125. Press enter. Okay, so I'm going to get out of the circle tool by pressing escape. Now, this is where I'm going to go a little different than I did in the in-person class. So, we got standoffs. We're going to do one at each corner. Okay, so there's going to be 2 plates. This is going to be 1 plate. The other plate's going to be identical to this one. They're going to be separated by standoffs. So, we're going to have gears in between those 2 plates, and we're going to have standoffs in between those 2 plates. And we need to make sure that those standoffs, excuse me. We need to make sure that those standoffs don't interfere with the gears, because if the gears hit the standoffs, that's going to be a problem. So, what we're going to do is turn on construction geometry again. Then we're going to use the offset tool, and we're going to offset this outer rectangle. Now, I know that I want the holes on the corners, right? And I want them evenly spaced from each side if possible. So I'm going to use the offset tool to make a rectangle that's offset symmetrically all the way around the gearbox. And I'm going to use that to locate the holes, and you'll see how that works here in a second. So offset tool, make sure construction geometry is on. Click on it. You'll notice the whole box highlights when I hover over it. So click on it, then move your mouse towards the inside. And you'll notice I've got this dimension showing up, and it's maintaining a constant distance all the way around. So we're going to do 1/4 of an inch, and I'll explain exactly what that means here in a second. We're going to do 1/4 inch, and we're going to press enter. Okay. Now, because I had construction geometry on, it made it construction geometry, which is exactly what I want. So I'm going to get out of the offset tool by pressing escape. Okay, so the corners of this dotted rectangle here represent where I want the centers of the standoffs to be. The standoffs are going to be round. They're going to be 3/8 of an inch. So up here at the top, actually, well, let's start down at the bottom. So keeping construction geometry on, we're going to draw a circle that represents the standoff as it's going through. We're going to make sure there's enough room for it. Now, there's quite a bit of room here, so I don't anticipate any problems. We're going to do it anyways. So here's a circle. I'm going to put it on the corner, make sure we get the green dot, place the circle. Now this is going to be 3/8 of an inch. You could type the equation in, like 3 divided by 8, and that works. Okay, so this is the diameter of our standoff, right? We can see there's plenty of space between the gear and the standoff. The standoff does not stick out outside of the plate. In fact, there's a nice little gap around there, which is helpful for structural rigidity and not deforming the aluminum. Okay, so now we can see from down here, up here, we're not gonna have any issues up here, but we're gonna place one up here anyways. So we're gonna place this down. I typed in the fraction before, but I'm just gonna type in the decimal equivalent here because I know what it is. It's 0.375. That's the same thing as 3/8. So I'm gonna press enter. You can see there's no, there's nowhere close. Now, we could do this on the other side, right? We could do all 4, but we know the gearbox is a mirror image of itself left and right, right? So we know it's symmetrical around the center. So we know the same thing's going to be over here. And we can see just by looking at this that we're nowhere near to having any interferences. Now, the reason that I'm talking about this is because on certain gearboxes that we do that are really tight on space, the location of the standoffs gets very close to the gears. I mean, there are gearboxes where we've got a standoff tucked right in here between the gears. Especially on our drive gearboxes, which have a lot of gears in them. So that's why I'm bringing this up. This is a good practice to do when you're designing a gearbox and doing a layout sketch like this, is to put the standoffs in there You should also be concerned about screw heads. Now, I know for a fact the screw head that goes into this is smaller than the diameter of the standoff. So if it clears the standoff, it clears the screw head. But in certain cases, you need to be worried about screw heads as well. So that's what we got. We know we're good. So what we're going to do now is we're going to draw circles that represent holes. So I'm going to turn off construction geometry here, and I'm going to draw another set of circles. Now, in the stand-up class, we use the hole feature for this. Now, you could do that, and probably if I was designing this gearbox myself, I would do that. I would use a hole feature to do that. But in order to use the hole feature and keep the layout sketch, you've got to do some slightly more complicated part organization, and I don't want to get into that right now. So we're just going to create circles and not use a hole feature. I've mentioned it in the class, I'll mention it here. That's not a good practice. The best practice is, if you're talking about holes, you should use the hole feature. And there's a bunch of reasons for that I won't go into here just for time. But so what we need is we need 4 holes on the corners. Now, I know that that's going to be a number 10 fastener, and I want a clearance hole. Right, so it's not a threaded hole. The threads are going to be in the standoffs, and the screws are going to come from the outside of the 2 plates, go through holes that we're creating here, and it's going to go into the threads in the standoff. That's what's going to hold the whole thing together. So I know for a fact the diameter of a clearance hole for a number 10 fastener is 0.201 inches. That's just what it is. That's 11 thousandths larger than the diameter of the screw, which is pretty standard for small screw sizes. So I'm going to go around and I'm going to create 4 more circles, and I'm not going to dimension them. So I'm just clicking, placing it down. And then what I'm going to do is I'm going to use the equals constraint. Pressing escape to get out of that tool. I'm going to use this equals constraint right here. And I'm going to click on one circle, and then I'm going to click on the first circle. Okay, and it makes the 2 equal in size. Now I'm going to click on this circle, and then the first circle again makes those 2 equal in size, and I'm going to click on the final circle, and then the first circle again, and it'll make those 2 equal in size. Now what this does, I'm going to get out of it. Let's say we make a change to our gearbox, right? We're in the build season. This is a gearbox that's going to be on our robot, and we change the design, and we need bigger fasteners here for strength or something. And I want to change this hole size. Okay. Well, if I had gone through and I had dimensioned each of these circles, I have to go in here and create and change 4 dimensions. Well, by using the equals constraint, I only have to change the size of this one hole, and then all of these holes will change with it. So I'm going to edit this dimension and demonstrate what I'm talking about. I'm going to make it something big, like 0.4 inches, right? Okay, and you can zoom out and see that all 4 of the holes changed. I can change it back to 0.201, and you can see they all change. So it's a good idea to do that when you know that 4 holes or 6 holes or 100 holes need to all be the same size. It's a good idea to make them that way through constraints rather than through dimensions. So we are done with this layout sketch. So what we're going to do is we're going to finish the sketch. Okay, we're going to use the extrusion tool up here. We're on the 3D model tab. We're going to click the extrude button. Now we can see that all of our profiles are green, and we can select this region. So just go in and click. Okay, you don't want to click the insides of any of the circles because we don't want to extrude that. We want that to be hollow because it's supposed to be a hole. So up here in the little extrude box, we want to make the distance to be 0.25 inches. Okay, it's a 1/4 of an inch. And you're going to click OK. Okay, so we can see here we have our plate. So we need to do a few more things. So the motor has 2 threaded holes. Okay, and what we're going to do is we're going to put the boss of the motor in this hole, and then we're going to thread 2 screws in from the outside into the motor. Okay, so we need to have those holes. So I'm going to place another sketch down on the front of this part using the Start 2D Sketch tool here. I'm going to click on that, and then I'm going to come and click on the front face of this gearbox. Okay, so now I know that the 2 holes are spaced evenly across the center line of the motor. The motor's round, as a lot of motors are. The shaft's in the middle, and the shaft is going to be inside this hole. And then there's basically a screw on either side of the hole evenly spaced. So what I'm going to do is I'm going to use a construction line to center that the way I want. So I'm going to create a line. I'm going to turn on construction geometry, and I'm just going to place the line. Now I'm going to take care to make the line horizontal, and you can see the little symbol right there to the bottom right from where my cursor is says that this line is horizontal. Inventor will automatically place a horizontal constraint, which is what I want. So I'm going to click. Okay, and then I'm done with lines, so I'm going to hit the escape tool to get out of that. So now I've got this line. This line can change in length, right? It doesn't have a length dimension, and I can click and drag it around and move it around, and it's not constrained at all. So what I'm going to do is I'm going to constrain the center point of this line to this point here, which represents the center line of the shaft of the motor. Okay, so I'm going to use the constraint, or the coincident constraint. I'm going to click that. I'm going to find the center point of the line, shown by the green dot. I'm going to click on that. I'm going to click on this point here, which represents the center point of the motor. Okay, so now if I get out of the coincident constraint tool by hitting escape, I can see the line is now centered here, and I can see that when I click and drag this, the line changes size. It's a little hard to see because it's over top of this line, but if I change the size of the line on one side, the end point of the other side changes equally, right? Which makes sense because we constrained it to the center point of the line. So what we're going to do is we're going to use these two endpoints to locate the mounting holes for the motor. But we need to know how far apart they are. We need to dimension that. So we're going to use the dimension tool up here. We're going to click on the line. We're going to place the dimension annotation up here somewhere. Now I know that these two holes are 29 millimeters apart. So we're going to type that into the box and press enter. Okay. Now, let me get out of the dimension tool there and move this annotation somewhere where I can see it a little easier. Now I know, yes. Anyways, okay. So the hole feature in Inventor looks for what's called a center point, and that's this tool right here. Okay, it's a center point. We're going to click that. We need to place these down at the end points of the line so that Inventor can find those points and place the hole centers there. So we're going to click. We're going to find the end point highlighted by the green dot. We're going to click. And we're going to go to the other end and place another one down here by clicking. Okay, I'm going to get out of that tool by pressing escape. So now we can see they're hard to see, but there's like two little dotted crosses. Those represent where the center of the hole is. So they're attached to the endpoints of that line, so we're done here. So we can hit finish the sketch. Then we can press the hole button. Okay, and you can see Inventor automatically finds the holes and places a little preview here of where the holes are going to be. Now we're going to change some settings because these holes are not the right size. Now if this, during the in-person class, we had a couple people who were having issues with Inventor not automatically selecting their center points even though it should have been. If it doesn't automatically do this, you can click this centers button. You can click on that button and then manually click on the center points and it should place the holes. If you accidentally click something and it places an extra hole that you didn't want, like here if I do this here by clicking on this and I click, oops, I unselected it. And I click here on this center point, I don't want a hole there. So to deselect that, right, to turn that hole off, I'm going to hold the control key and I'm going to click on that point again and it goes away. Okay, that's what I want. All right, so these holes are going to go all the way through the plate. So the termination is going to be through all. Okay, you'll notice the holes kind of shrink to go only all the way through the plate, which is what we want. So if we change the thickness of this plate down the road, the holes will change in depth. Okay, so what we're going to do is we need to create a clearance hole. Okay, so down here in this row of radio buttons, we're going to click the second one over, which you can see by the tooltip there says clearance hole, so we're going to click on that. Now, it's weird. It's like the first time you open Inventor and the first time you use the hole feature, it takes like a minute to load. There's a big database of all the different hole sizes and stuff that Inventor has to load, and for some reason the first time you do it, it takes a while. Once we do this, we won't have to wait on this again, but there it goes. Okay, so this motor is all metric sizes, all the dimensions on the motor are in millimeters. So what we're going to do here up under standard, we're going to pick ANSI metric M profile. That's for metric screws. This top one here is for English sizes. This bottom one here is for metric, and there's some other different standards here that I don't think I've ever used. Okay, so metric M profile. Ignore the fastener type for what we're doing. This doesn't make a difference. If we were countersinking or counterboring, we would want to select this. The size is going to be an M4. I didn't look that up, but I think that's what the size of the motor is. If it's not, we can always come back and edit this. The fit should be normal, so that's fine. You'll notice the holes got a little smaller when I selected that, or actually they got bigger. But anyways, they're the right size now. And you can see that it's a metric hole, but it's showing the dimensions up here in inches. I think that's 4.5 millimeters, I think is what it ends up being. So we're going to click OK. And now we got 2 holes. Okay, so we have one more thing we need to do. This motor has vents on it, and the vents are on the face of the motor, right, the front of the motor. So we're gonna attach the face of the motor to this plate, and it's gonna be squashed up against this plate. And there's holes there that pull air in that cool the motor. Okay, so if we just bolt the motor up to this plate like we are here, air won't be able to get into the motor, and the motor will get hotter quickly, and the motor could burn out. So what we're going to do is we're just going to add some just kind of roughly positioned holes around that. Will allow some air to go into those vents. They don't need to be perfect. They're just going to be quarter inch holes, which is a really easy size to drill. And we're just going to position them kind of roughly here. So what we're going to do is we're going to create another sketch by clicking this button up here, and then we're going to click on the front face of the gearbox plate. And now we're in a sketch. So what we want to do is we want to create 4 holes evenly spaced on a circle, right? It's going to be a circle, and then there's going to be 4 holes that are evenly spaced around that circle. So what we're going to do is we're going to turn on construction geometry. We're going to grab a circle. We're going to do this. And I think we're going to do 1 1/8 inch bolt circle here, or hole circle, I should say. So that's going to be 1.125. That's just what looks good. Also, for the other class, we modeled this before, and I think that's the dimension we used. Okay, so now we need to evenly space holes. Or when I say holes, I mean center points. So we're going to locate center points, and we're going to use the hole feature like we just did for these 2 holes here. So we need to evenly place center points. Now, the easiest way to do that I found is to use a polygon, right, with the number of sides of the number of holes you want to create. So in our case, we want to create 4 holes, so it's going to be a 4-sided polygon, which is going to be a square. So what we're going to do is we're going to go up to rectangle, and we're going to find a 2-point center rectangle, which is basically a rectangle where instead of specifying 2 corners, we specify the center and 1 corner, which is pretty useful. So we're going to click on 2-point center rectangle. We're going to click on the center of the circle, and then we're going to click on the circle itself. Make sure it snaps to the circle. You can see that little yellow dot there. Okay, so we place that down. Now we've got a rectangle. It's not a square yet. Okay, so I'm going to get out of the rectangle tool by pressing the escape key. Now, we want this to be a square, which means the 2 sides of the square or the rectangle need to be equal. So we're going to use the equals constraint to do that. We're going to use, click it up here, and we're going to click on the top of the rectangle and then one side of the rectangle. And you'll notice all of a sudden it becomes blue, which means it's fully constrained, which is exactly what we want. And now it's a perfect square. So I'm going to hit escape to get out of this tool. Now I'm going to do like what I did before with these 2 holes. I'm going to grab the center point tool, and I'm going to click on each corner of the square, making sure that I'm getting this green dot before I'm clicking. It's really important to look at what your mouse cursor is before actually clicking, because if it does a different thing if you have yellow versus green dots. So we're done here. I'm going to get out of this tool by pressing escape, and I'm going to click finish the sketch. Okay, so now we've got these 4 hole center points. We're going to click the hole tool. Now it keeps the hole wizard, and most tools in Inventor keep the settings that you used last. Okay, so what what we're going to do here is we're going to go back and click this normal dimensional hole. Not sure what it's actually called. Tooltip's not showing up here, but we're going to click this first one here, which is just a normal dimensional hole. And then in this box here, we're going to type in the diameter, which is going to be 0.25 inches. Okay, you'll notice the whole preview here changes size as we make changes to settings here. So once again, if the points don't automatically select, click centers and manually select them. So click OK. But in our case, that's not a problem. So yeah, click OK. And there's some holes that'll allow air, plenty of air to get through to the motor, and the motor will stay cool. Okay, so now we want to round the outside corners of this gearbox. And that's just for if you machine this plate or laser cut it or something, we don't want any sharp corners. It's also easier on a CNC machine to cut nice smooth curves than it is to do sharp corners, especially with a laser cutter or a water jet. A CNC is not quite as much of an issue, or a CNC mill is not quite as much of an issue, but yeah. And then in addition to that, it just looks nicer to have nice large round corners. So we're going to use the fillet tool up here on the ribbon. We're still under the 3D model tab. We're going to click the fillet button. Now in the class, I think I just used this default radius of 1/8 of an inch, which is good in most cases. In this case, I want to make this 0.25 inches. So you type in 0.25, and then you just come over here and you click on the edge that you want to radius. So I want to radius this edge up here at the top, right? You can see how it rounds this corner off really nicely. Okay, that's what we want. So I'm going to click all 4 of the edges. You're going to have to use the orbit tool, or the orbit feature to do this. If you don't remember how to do that, you hold the shift key, you press down the mouse wheel, right, which is the middle mouse button. Press down the mouse wheel, and then you move your mouse around to orbit. You can also left click and hold and drag on this little view cube up here in the corner. The view cube tends to snap to different, like the front view and stuff, so it's sticky and it drives me nuts when I'm using it, so I never use it, but a lot of people do. So alright, anyways, finish selecting these corners. Now, if you accidentally select an edge that you don't mean to, right, I just selected the top, and I don't want the top edge like that to be filleted. And I want to deselect that, right? I want to turn that selection off. So I'm going to hold the control key, and I'm going to go back and I'm going to click on that line again, and it'll unselect it. It'll remove it from the selection. And over here in this little dialog box here under edges, it'll show you how many you have selected, so that helps a little bit. Okay, I'm going to click OK because I'm done, and there's our part. Go to the home view here. Now we've got a couple more things to do. We're going to go up here to this box that's up here at the top where it says generic. We're going to click the drop down arrow. We're going to scroll up in the list. We're going to pick aluminum 6061. Okay, you'll notice the color changed slightly. This box here, this drop down box here, is the appearance. We can change the color if we want. I'll select blue, okay, and make our plate blue, because on Stellar Robotics we paint everything blue and sometimes yellow. So okay, so there's my part. I'm done and I'm ready to save it. So I'm going to go up here to the top and click the save button, and I'm going to go to this folder here, and I'm just going to put all the parts for this gearbox in here. So I'm going to do that's for CAD class gearbox, and then I'm going to give it a number, and then I'm going to click save. Okay. All right, so that's our finished gearbox plate. I'm going to stop the video here. Next video we're going to model standoffs and shafts, and then we'll move forward with importing components and assembling. So thanks for watching.